The ideal gas law is simply an equation, PV equals nRT, where P is the pressure, V is the volume, N is the number of moles of gas, and T is the temperature. All of those quantities need particular units for using this equation. Temperature, as always, has to be in Kelvin. N is number of moles, so that's always what the unit is for N. Volume should typically be in liters, and then pressure, you could have kilopascals, you could have atmospheres, you could really have any pressure unit you wanted or any volume unit you wanted, but the pressure and volume unit that you have are going to control the value of this universal gas constant. Typically these are the two values of the gas constant that are given, and the one that you use depends on what the units are for your pressure and your volume. Now the ones that I've given you here require the volume to be in liters. You can see that we have 8.314 liter kilopascals, and in the bottom 0.08206 liter atmospheres per mole Kelvin. For my problems in my classes, the volume always has to be in liters. The pressure, if it's in kilopascals, you want to use the 8.314 number. If it's in atmospheres, you want to use 0.08206. You could calculate other values for R with other pressure units, but those are the two I give, and of course we can always convert one pressure to another. So let's try this example. 0.25 grams of carbon dioxide fill a 350 milliliter container at 127 degrees Celsius. Find the pressure in millimeters of mercury. We're going to use the ideal gas law. We want to find pressure, so we're going to divide both sides of this equation by V. That's going to give us nRT divided by V on the right side of the equation. So let's find the values of these quantities. What's N? Well, N is the number of moles. Well, we're not given the number of moles, we're given the number of grams, but we're given the number of grams of a particular substance, namely carbon dioxide. We can find the molar mass of carbon dioxide from the periodic table. Make sure we cancel our unit of grams. 0.25 divided by 44, there's the value of N. Okay, we've got the value of N. R is just a constant, so we don't need to worry about that. We can just look that number up. How about V? V in the problem is given as 350 milliliters, but we talked about how to use one of my values for R, right? One of the two values that I provide my students. We need to have the volume in liters. 1 liter is 1,000 milliliters, 0.35 liters. There's our value for V. What about temperature? Temperature has to be in Kelvin, so let's convert it by adding 273 to the number of degrees Celsius, and that gives us 400. So now I think we're ready to go. I'm going to go ahead and choose the R value of 8.314. I know my temperature is in the right unit. I know my volume is in the right unit. There are the number of moles. When you calculate that, you get 54.0. 54.0 what? The pressure is going to be kilopascals, because this 8.314 number that I picked was in kilopascals. See, if I had provided an R value for millimeters of mercury, we would use that, because at the top of the screen you can see that the problem specifically asks for the pressure in millimeters of mercury. But we don't have an R value for millimeters of mercury in this lesson, so now we're just going to convert kilopascals of pressure into millimeters of mercury. We're supposed to know that conversion, and there we go, 405 millimeters of mercury.